Thanks for the privilege and welcome again to our next class as we continue with our mathematical series. In this class, we're going to consider indices. Now, before I continue with, before I properly talk about indices, let me start with the word index. Now, what is index? The index of a number simply means a number that can be raised to the power of. The index of a number is any number that can be raised to the power of. Any number that can be raised to the power of. Now, in this case, the index itself indicates the number of times a particular number can multiply itself. The index indicates the number of times a particular number can multiply itself. Now, I'm pleased to tell us that indices generally is very important in mathematical series, or is a mathematical term that is very important, that enables us to write some mathematical expressions compactly. It enables us to write some mathematical expressions in a compact form. That is, instead of writing the multiplication of a particular number, you can use this notation to just write it compactly. Now, how do I mean? Instead of, if we are considering, say, a number, say y, or say a, where it multiplies itself severally, so this one means a times a times a times a, a multiplying itself n times. Now, instead of writing these long expressions in terms of indices, if you want to write it in index form, you say, being that it is n time, you say a raised to power n, instead of writing this whole thing. Now, this one simply means a times a times a times a into n times. So it's a convenient tool that enables us to write some mathematical expressions compactly. It's a mathematical tool that is a convenient tool that enables us to write some mathematical expressions compactly. Now, this word is a singular term. Now, the plural term of index is what we refer to as indices. The plural term of index is what we refer to as indices. Now, this is what it is. Instead of writing something in a multiple ways, in n times, you can just write it in a compact way. Meaning, if I am to write 2 times 2 times 2 times 2, in index form, I can just write this 2 raised to power 1, 2, 3, 4. 4. Where if you determine the answer 2 times 2, it will give you 4 times 2, 8 times 2, 16. And the resulting answer here is also 16. It's a compact way of writing some mathematical expressions. Now, let's consider some rules that will enable us to go through to properly understand what we want to learn. There are some laws that enables us to resolve this reasonably. One of them is the multiplication of indices, the multiplication law of indices. Multiplication law of indices. The multiplication law of indices. In it, we are going to consider it in different cases. Now, case 1. Case 1. If we have, say, some expression in a compact way, but such that it multiplies itself, where this A that we have is the base, and the power here, we said you can call it index, you can call it the power, or you can call it exponent. These ones here, you can call it index, you can call it power, or you say exponent. Whereas these ones here are the bases. The base. Now, if we have an expression of this form, where it multiplies another expression of this kind, as we have stated, we said this one here is the base, while this is the power. Now, if you look at these as two expressions, the operator in between them is multiplication. Now, in this case, where the bases are the same, Law of Indices states that we take one of the base, then you add the powers. You take one of the base, then you add the powers. So if you have this kind of expression, all that we need to do is to take one of the base and then add the powers. Then add the powers. Meaning, if we have, for instance, this times say 3 times 2 to 2, what do? In indices, being that the bases are the same, we take one of it, then we add the powers. We add the powers. And this will be 2 raised to power 5. And or if we want to write this expressly as we did, in this case, this one is the same thing as 2 times 2 times 2, 3 of it, times another 2 again, 2 times 2. How many are they? 1, 2, 3, 4, 5, which is the same thing. So in this is just telling us that instead of writing this thing in this form, just collect the bases, then add the powers. That is case number 1. So in case you have anything, any expression where the bases are the same, then the operator in between is multiplication. All that you need to do is just to collect one of the base, then add the powers. Now if we have again, say 3 into 3 times 3 into 2, what do we do? Or 3 into 2, what do we do? As we know, as we stated in this case, this one is same thing as 3 times 3 times 3, that is covering this side, times 3 times 3, which is 2 of it here, which is 1, 2, 3, 4, 5. But instead of writing this thing like this, Law of Indices say just take one of the base, which is this, because the bases are the same. You take one of it, then you add the powers, 3 plus 2, which will give us 3 into 5. That is what we have. Now, case 2, let's consider another case. Case 2. Case 2 is when the bases are not the same. This one that we have considered is the bases are the same. What if the bases and the base are not the same? Like we have a raised to power m times b raised to power n. This is still indices because we have a particular number that is multiplying itself n times. A particular number multiplying itself n times. Here a particular number multiplying itself n times. So in this case, what do we do? Or sometimes we can also have it in this form, this b, all into bracket this. Where you can see that the bases are a, b, but n in all. In this case, what do we do? Now, if it is in this case, all that you need to do is you don't collect as we did when the bases are the same, but in this case, all that you need to do is to resolve them individually. is to resolve them individually. So how do I mean? Like, example, if you have maybe 2 raised to power 2 power 3 times 3 raised to power 2. Now in this case, you can see that this is a number multiplying itself 3 times. This is a number also multiplying itself 2 times. Now, we are saying that being that the bases are not the same, we are not going to do what we did the other time by just collecting one of the base and adding the powers. No, because the bases are not the same. But in this case, what we need to do is to resolve this one on its own, resolve this one on its own, then before you bring in them together, So in this case, we have 2 times 2 times 2, 3 of it, and we have here again 3 times 3, 2 of it. So if you resolve that, you are going to have, I said resolve them singly. So in this case, you are going to have 2 times 2, 4 times 2, 8. This one is 3 times 3, we are going to have 9. So all that you have here is 8 times 9. What is 8 times 9? Those of you that are not used to your timetable, you use your calculator and you give us the formula, the answer. And the answer will be, you said 8 times 9. The resulting answer is 72. 72. The resulting answer is 72. So this one, the answer that you're going to have is 72. So what I'm trying to say is that being that the bases are not the same, all that you need to do is to resolve those individual terms individually, singly, then you bring them together. Like in this one here, assuming we have separate terms, you can also rewrite this one as A into M, B into M. You bring them in this form. So this is how it is. In the first case, the bases are the same. Then I said collect one of the base, then add the powers. But this one that the bases are not the same, all that you need to do is to resolve the individual terms, then you bring them together. Now the next one I want us to consider, that which is case 4, case 3. Case 3 will be, in the indices we have a coefficient, say k raised to power m times, note that we are dealing with multiplication law of indices, times say r a raised to power n. Now in this case, if you look at it critically, you can observe that the coefficient, the initial ones, the coefficients are just 1. But in this one, the coefficient here is unknown, though is k, is a constant. Here is r, is also a constant. Now in this case, what you need to do is, yes, the bases here are the same, but before you collect the bases, you multiply the coefficients first. So you're going to write it in this form, a k times r, then you collect one of the base, which is a, because the bases are the same as we did in the first case, then you add the powers. So in this case, all that you need to do is to multiply the coefficient first, as we have done here. Then, being that the bases are the same, we collect one of them, then we add the powers. This is how it goes. Now let's assume we have an example of this form, say 2, say 3, where we have a raised to power 2 times 2, a raised to power 3. How do you write this? How do you resolve this? I said, first of all, multiply the coefficient. So if you do that, you're going to have 3 times 2, which are the coefficients. The bases are the same, so we take one of them, then you add the powers. 2 plus 3. So here we're going to have 6. A raised to power, when you add this, you're going to have it as 5. So in this third case, you can see that all the difference is just the coefficient that we have. Now, the fourth case that I want us to consider is, this is another case, the fourth case that I want us to consider is a case where the powers, the index is unknown, is not known. A case where the index is not known. A case where the index is not known. All the ones that we have considered, we assume that the powers are known. But if we assume that the powers are not known, what do we do? Like if we have a raised to power m times a raised to power 2 equal to, say, another expression, a raised to power 5. Another expression, say, a raised to power 5. Now what do we do? Now if you look at them, if you look at this other side, you can see that the index here, the power here is unknown, is not known, while the power here is known. Now on the right hand side, across the equal sign, you can see that the power here is known. Even if all the bases are the same, the base, you can see that they are all the same. Now, if you have to concentrate on the left hand side first. Now, when you consider this side, you will see that the bases are the same. So we have to apply the first case that we employ, the first case that we considered, where being that the bases are the same, we take one of the bases, then we add the powers. We add the powers equal to, we have another expression, a raised to power 5. Now, after writing this thing down in this form, all that you need to do is look at it. You can see that the bases here are the same, the bases here are the same. These things are equal. The base here is the same, the base here is the same. So this one and this one can go. And you just have m plus 2 and 5. The bases are the same, the bases are the same. So you taking out the bases, then you are just left with the powers. Now, once it comes to this form, you can see that this unknown here can be determined. You can make it the subject of the formula by saying m equal, taking this one to the other side of the borderline, then you have 5 minus, here is positive, crossing to the other side, become negative, then 2. So you have your m as m equal to 3. So you can determine your m using this form. Now look at what we did first. Now initially it was like this. All that we did was, first of all, we employed the first case here, and we arrived at this answer. Having done that, the next thing is, you can see that across the equal sign, the base here is a, and also here the base here is a. So we assume that they are all equal. So you cross out the bases, then you consider the powers. Having done that, this is the stage that we are onto. Now the next one is making the m here the subject of the formula, and you can see that it's just as simple as ABC. Let's consider another case, say 2 raised to power m times 16 1/2 is equal to 8 raised to power 2. Now if we have this kind of problem, how do you resolve it? This is also indices. How do you resolve it? Now in this case, you can see that the bases here, initially they are not, arbitrarily they are not the same. But we know that the bases are the same, because the 16 here, you can express it in terms of 2. You can raise it in terms of 2. 8 here also, you can also raise it in terms of 2. So those of you that are not looking at it critically, you may say, the bases are not the same, this thing cannot be resolved. It can be resolved, because you can see that like 16 here, 16 is the same thing as 2 times 2 times 2 times 2. And 8 here is 2 times 2 times 2. 2 times 2, 4 times 2, 8 gives you this one. So you can rewrite this 16 in terms of 2. And you can also rewrite this in terms of 8, so that you can have a common base. Now, how do we do? If that is true, you know that this expression here, you can write it as 2 raised to power 4, which is the same thing as 16. Which is the same thing as 16. While this one 8, you can write it as 2 raised to power 5. So in place of 16, we can write 2 raised to power 4. We can write 2 raised to power 4. So first of all, we have 2 raised to power m multiplied by, in place of 16, 2 raised to power 4. 2 raised to power, but we have another 1/2 multiplying it. 1/2 multiplying it. equal to, in place of 8 here, we put 2 raised to the power 3, but note that we are having 2 there already. Now, after that, you can bring them together. You can bring them together. This one still remains here, 2 raised to the power m, multiplying, when you multiply this one, when you simplify that one, you're going to have 4 over 2, which is 2, equal to this will give you 2 raised to the power 6. 2 raised to the power 6. Now, as we did in the other case, all that you need to do is to resolve this other side. Be that the bases, the left hand side, be that the bases are the same, you take one of them, which is 2, then m, which is unknown, plus this other power, equal to 2 raised to the power 6. Now, it now looks like the other case that we considered. The bases are the same, so you take them out, then you have m plus 2 equal to 6. Then making m the subject, you take 2 to this other side, so you have 6 minus 2, and your m will be equal to 4. So you can see that all these things are just simple indices. Those of you that are going through JAMB and WAEC and all the rest, all these things are objective questions, and or sometimes some question number 1 in mathematics that you can go to. They are as simple as ABC. Once you have something in terms of index, in terms of power, try to see if you can use any of the law of multiplication of indices to resolve it. Even if it's in other operator, you can also resolve it. As we go on, I believe you are going to have a more understanding in what we are doing. So now we have considered 4 cases. First case, the case where the powers and the bases are just the same. Second case where the bases are not the same. Third is a case where we have a constant. And fourth is where the powers are, one of the powers is unknown. Then how to resolve? That's what we have just done. Let me write another expression where we have a mix-up of different bases, but still employing one of the cases that we have considered. Now, in doing that, let's just consider this one where we have 2y raised to the power 3, x raised to the power 3, times 6, y raised to a combination of all that we have done, 5, and x raised to the power 4. Now, if you have this kind of expression, how do you go about it? It's still as simple as ABC. Now, first of all, the other case, it looks like one of the cases first, where we have coefficients. The coefficient here is 2, the coefficient here is 6. And we said, if that's the case, multiply the coefficient. So the first thing to do is to multiply the coefficient. This is what we have. Then the other thing is, you can see that in this other side we have y as a base. This other side we also have y as a base. Why? The operator is multiplication. And what we have learned is that if the bases are the same, that we should add the powers. So if we consider y, then all that we need to do is to collect one of the base, then add the powers. Here is 3, here is 5. Then we still have another base which is in x, and we also have it here again. So, and the operator in between is multiplication. So all that we need to do is to also add the powers. Here is 4. This is all that we have. If you can look at it now, we have resolved all of them. So if you multiply this, you're going to have 2, and this one we have y. When you resolve this, you have 8. X, when you resolve this, you're going to have 7. So it's just as simple as ABC. If you can understand the concept of indices, the multiplication of indices, all that we have presented here is as simple as ABCD. For the case of this class, we're going to bring this to a close now. But before you go, please try as much as you can to click on the subscription button as we consider other laws of indices in our next class. Thank you and God bless you.